All right, we're on video lesson number 3 of our review unit. It's talking mainly about the distributive property and specifically how that affects expressions and even equations. So let's go over some terminology first. Before we go over the distributive property, I want to talk about terms and coefficients. Now, a term is just a number, a variable, or a product of those in a number and a variable that are in an expression. So expressions, those statements, are built up of terms. Now, in something like this, an expression x squared plus 3x minus 5, there are 3 terms here, 1, 2, and 3. And terms are always separated by adding and subtracting. So it's always separated by a plus or a minus sign. So the terms we have are an x squared, a 3x, and technically this is a negative 5. We can call this plus negative 5. If they're separated by a minus, just change it to a plus, a negative version of that. So x squared, 3x, and negative 5 would be our terms, the 3 terms in this expression. A coefficient then is the numerical part of a variable term. So if we have a term that says 3x, like this one right here, the coefficient is 3. It's just the number that goes there. Now, when it said x squared, this piece here, the coefficient is technically 1. So it's saying 1 times x squared. There's only one of them. There are 3 of these x's. There's 1 of this x squared. And we can't combine x squareds with x's because they're not the same number. If we were to plug in, say, 2 for x, well, x's are 2's. X squareds are actually 4's because 2 squared is 4. We can't combine 2's with 4's. Okay, they need to be the same thing. So, coefficient, one thing to think about, it can be a negative. So like in this example, negative 4y has a coefficient of negative 4. That is possible. That is okay to have negative coefficients. Now, using that information, let's go back to the distributive property. Now, essentially, the distributive property is saying when you have a coefficient, like this letter A, that's outside of a parentheses, where we have 2 terms, b and c. So a is called the coefficient because it's the numerical value on the outside of this parentheses. You would distribute or share that coefficient with each term. So a times the amount b plus c is actually going to come out to be the same thing as a times b plus a times c. Same thing if it was a minus, a times b and a times c with a minus in between those two. So basically what it means is the outside factor, or this coefficient, is shared with each inside term. So, example 1, we need to simplify this expression. This is not an equation, there's no equal sign, we just simplify the expression. Now sometimes our coefficient, or the factor that needs to get distributed, will be on the end, and that's totally okay. Because remember, if we have this little expression, 3 minus x times 4. That's what this is saying, times 4. Well, multiplying is the same as addition. You can use the associative and the commutative property. You can move this around, put the times 4 out front here. It means the same thing. So 3 minus x times 4 is the same as 4 times 3 minus x. So when we distribute that, the 4 goes to the 3, and the 4 goes to this minus x, or the negative x. 4 goes here, 4 goes here. So our first step in simplifying this is to distribute, and we would get the 9x stays the same. 4 times 3 is 12. 4 times negative x, or negative 1x, or minus 1x, however you want to think of it, 4 times that amount becomes minus 4x. So right now, this would be our expression. And we're done with the distributing part. But now we need to look at our terms and combine any like terms. This is an x term, and so is this. This one is what we call a constant term. There are no variables with it, so it's just a constant number. It's just a 12. This 9x and this negative 4x, well, they will vary. It depends on whatever x equals as to be what this term is. So if x was 0, these would both be 0. If x was 1, well, this part would be a 9, and this would be a negative 4. If x was 3, this would be a 27, and this would be a negative 12. So these ones vary. This one is constant. It's always going to be just 12. So we can't combine 12 with these two, but we can put these ones together. 9x and a negative 4x, if we add those together, becomes a 5x. So just 5x's plus 12. So in the end, this would be your simplified expression, 5x plus 12. Example B, we have 2a minus 6, and this minus 6 is being multiplied by a minus 7. Now, one thing I want you to recall, we've talked about this before, SMATO means subtraction means add the opposite. Anytime you see a subtraction sign or a minus sign, you can change it to adding and then just call it a negative of whatever you were looking at. So in this one, if our first step is to SMATO everything, this minus turns into a plus negative 6. So it's not 6 times all of this, it's negative 6 times all of this. Same thing with this minus 7. It's not minus a 7, it's add a negative 7. Subtraction means add the opposite. Now that might make it a little bit easier to see how everything works here. Because this negative 6 is on the outside of the parentheses, we need to distribute. So it needs to get multiplied to each one of these. Now here we'd be able to see that it's still being multiplied to each one, but it might not be as easy to see that this is a negative 6, and this is technically a negative 7. So negative times negative. Also negative times positive here. So now that we can see it a little bit easier, after we distribute, this is what our expression looks like. The negative 6 times a became a negative 6a. Negative 6 times negative 7, well, negative times negative is positive, so we're adding a positive 42. Now we need to combine any like terms. Here we have an a term, positive 2a. Here we have an a term, negative 6a. And here we have a constant term, just the number 42. So these two can combine, but this one will not combine with them. After we combine everything, we get a negative 4a plus 42. So all of this, 2a minus 6 times a minus 7, that can be combined or made a little more simple into just negative 4a plus 42. All right, and we have one more example here, just taking our expressions. Now we have 6n being multiplied by this piece in the parentheses, negative 2n plus 1. At the end of all that, we're subtracting 10n squared. So, because it's 6n that's being multiplied by all of this, we need to think of that as one big factor on the outside. That whole piece needs to get multiplied by each of these pieces. And remember, each term is separated by the plus or the minus sign. So, here we have a term, negative 2n. And here we have a term, 1. And we need to distribute this 6n to each one of those, not just one, but each piece. So when we distribute 6n times negative 2n, well, the 6 and the negative 2 become negative 12. The n times the n becomes n squared. So just this multiplication piece became this term right here. Now we do 6n times this positive 1. It just leaves us with 6n. And at the end, there's still this minus 10n squared. So that's right here. Now again, we need to look at combining any like terms. This first term right here, we'll cut it off at that plus sign, negative 12n squared. We can only combine this with n squareds, not n's. This 6n does not have a squared, so this is a completely different kind of term. We cannot combine these ones. However, 10n squared can be combined with negative 12n squared. And because this is minus, we're going to SMATO it really quick and call it plus a negative 10. So we have negative 12n squared being combined with a negative 10n squared. So negative 12 plus negative 10 becomes negative 22. So we have negative 22n squared plus this 6n at the end. And that would be our simplified expression. Example 2. Now we need to start using this distributive property with equations. So we need to solve this equation. 80 equals negative 4 times the amount 1 plus 3k. Well, we need to distribute because we have those parentheses, so negative 4 times 1 and negative 4 times 3k. After we distribute, our equation looks like this. Negative 4 times 1 is negative 4. Negative 4 times 3k is negative 12k. Now we need to think about how do we get k alone. This is going to be similar to the things we did in our last lesson. Well, it looks like the last thing that would happen to k, well, the first thing is we do k times negative 12, then we add negative 4. So what would we do to both sides? We would add that 4. We get rid of that minus 4. If you need to think of it this way, we're subtracting a negative 4. Remember, subtract a negative means the same as adding. That's why it says add on both sides here. When we do that, our equation now looks like this. 84 equals negative 12 times k. So again, what do we need to do to both sides to get k alone? This is saying k times negative 12. So we'd have to divide both sides by negative 12. When we do that, we get that negative 7 equals k. 84 divided by negative 12 is negative 7. And we now have k alone. Example 3, we need to solve this equation, negative 8 minus this whole piece, negative 2 plus 3n equals negative 15. Now, because this doesn't have any coefficient in front of it, but it does have this minus, we're going to put in our hidden coefficient of 1. This is saying 1 times all of this. But because it's minus 1, you might want to SMATO it and call it negative 8 plus negative 1 times all of this equals negative 15. Because this was minus all of this, we'll call it plus a negative 1. Now that we have the negative 1, now we can distribute. In a sense, because it's just minus 1 and 1 isn't going to change these, you can also think of it as this minus means each of these signs is going to change. Because in the end, this is what we get. Negative 8 didn't change. This negative 2 is now a positive 2. This positive 3 is now a negative 3. Because negative 1 times negative 2 is positive 2. Negative 1 times positive 3 is negative 3. So we have negative 8 plus 2 plus negative 3n equals negative 15. Combining any like terms, again, we have 3 terms on this side, 1, 2, and 3. These 2 are constants. This one is a variable. It's an n term. So these can combine to a negative 6. This one stays as negative 3n. And we can mix and match those. We could leave the 3n at the end, but we decide to put it out front here, make it a little bit easier to see what we're doing to both sides. So it's negative 3n plus negative 6 equals negative 15. So now, how do we get rid of this negative 6? Again, we're thinking if we add negative 6, we need to subtract negative 6 from both sides. But subtracting a negative is the same as just saying adding. So we would be adding 6 to both sides. So now it says negative 3n equals negative 9. How do we get rid of this n times negative 3? Well, we would divide by negative 3 on both sides, which leaves us with n equals 3. And that would be our final solution. That would be how to solve this equation. Example 4. We're now moving into proportions. We have 7 over 8 equals m plus 10 over 10. Now, because it's a proportion, we can cross multiply. 7 times 10 is 70. We know that one. 8 times all of this, because it's all in the numerator together, we need to think of it as one big piece in parentheses. All of this is getting multiplied by 8. So this is what it would look like after cross multiplying. 7 times 10 is 70. And we have 8 times all of this, m plus 10. Now, we can distribute. 8 times n, 8 times 10. So we would get 70 equals 8m plus 80. Now, to get to m alone, the last thing happening to m, we would do m times 8 and then add 80. So we need to subtract 80 from both sides. And we would get negative 10 equals 8m. To get m alone, we divide both sides by 8. And we would get negative 10 over 8 equals m. Or you can call it m equals negative 1 1/4. Or you can call it negative 1.25. Any of these three answers will work. The improper fraction, the mixed number, or the decimal number. They all work for answers for m. And we have one more proportion here. 8 over x minus 5 equals 2 over 3. Two fractions set equal to each other, so we can cross multiply. Again, remember, since 2 is being multiplied by all of this, we need to think of it as all one big piece in parentheses underneath the 8. So after cross multiplying, this is what it looks like. 8 times 3 is 24. X minus 5 times 2 looks like this, x minus 5 times 2. Note, you can SMATO that if you want. If you want to call it x plus negative 5, oops, like that, and then say that all of that is getting multiplied by 2. So it's 2 times x and 2 times negative 5. That might help. You don't have to do it that way, but that might be a way to keep yourself organized. After we distribute the 2 to each piece, it now looks like this. 24 equals 2x minus 10, or again, you can think of it as 2x plus a negative 10. Either way, still means the same thing. We would add 10 to both sides. How do we undo a minus 10? We add 10. So now it says 34 equals 2x. And how do we get rid of that 2 from the x? Well, we divide by 2, and we would get that 17 equals x. And that would be how to solve this proportion. And that should actually be it for this lesson. That'll cover it for our review unit.